Welcome everyone. So today we move on to the next topic in the subject Environmental Engineering 1, Module 5. In the previous class we discussed what is disinfection and what are the various minor methods of disinfection. Today we will be discussing what is chlorination. We know that chlorine has been widely accepted as a disinfectant, and it is very much used everywhere because it is cheap, reliable, and also presents no great difficulty in handling. It is very easy to handle, and this is why it is widely accepted. And also at very low concentration also this is very much effective. It is also cheaply available, and it forms residual if it is applied in sufficient dosages. So when we apply or disinfect water using chlorine, there will be residual chlorine present in water, which will help when there is further contamination in the water due to when it is distributed through the distribution pipelines. So suppose there is a leakage or anything and further the water gets contaminated, if there is residual chlorine present in water, it will effect disinfection during the process of distribution. Now chlorine is applied either as gas, that is in the form of free chlorine, or as a hypochlorite, that is by using bleaching powder. Now coming to the exact theory or the action by which the chlorine kills the bacteria in water, there are so many theories which have been put forward, but among all the theories, the theory of the enzymatic hypothesis is the most accepted theory. So as per this theory, the chlorine compounds formed when chlorine is added to water will interfere with certain enzymes in the bacterial cells which are vital for the support of life, and the enzymes involved are created within the cell plasm, and hence action of the disinfection proceeds in two steps. Firstly, the penetration of the cell wall by the disinfectant, and secondly, its reaction with the enzymes. So when chlorine is dissolved in water, what happens is it will react to form hypochlorous acid, or it dissociates to form hypochlorous acid and hydrochloric acid. So the hypochlorous acid HOCl will ionize or dissociate into, further it will dissociate into H plus ions, that is hydrogen ions, and hypochlorite ions, OCl minus ions. So again the dissociation of HOCl is a function of the pH. So it is the hypochlorous acid and the hypochlorite ions which actually accomplishes the disinfection process. So when chlorine is added to water, all the three, that is elemental chlorine, then the hypochlorous acid and the hypochlorite ions will be formed, and they will remain in equilibrium at different concentrations depending upon the pH of the water. It is actually the pH which controls the amount of the dissociation. So the chlorine existing in water as hypochlorous acid, hypochlorite ions, and molecular chlorine is defined as a free available chlorine. Now the actual disinfection efficiency will depend upon the ratio of the hypochlorous acid, that is HOCl, and it will depend upon the hypochlorous acid and also on the concentration of the it depends upon the ratio of the hypochlorous acid, that is HOCl, to the ratio of the hypochlorite ions, so being greater at a higher ratio. So whenever the pH is less than 5, chlorine will exist as elemental or molecular chlorine, that is Cl2, and when the pH is between 5 to 10, like you can see in this figure, when the pH is less than 5, the chlorine will exist as elemental or molecular chlorine, and at a pH between 5 to 10, that will remain in the form of both HOCl and HCl, hypochlorous acid and hypochlorite ions. Now the concentration of the former will be reduced and that of the latter will be increased as the pH keeps increasing. So like you see in the figure, it will keep increasing, and when the pH is greater than 10, only the hypochlorite ions will exist, since the hypochlorous acid is about 80 times as effective as the hypochlorite ions. The pH of the water to be treated should be maintained at a value less than 7 in order to prevent ionization of HOCl or hypochlorous acid. So here you can see this is depicted here. When it is less than 5, only elemental or molecular chlorine will be present. Between a pH of 5 to 10, both HOCl and OCl minus will be present. And when the pH is greater than 10, only hypochlorite ions will be present. Now, coming to the what is meant by chlorine demand. So chlorine and chlorine compounds they are actually highly oxidizing in nature, and they will first react with organic as well as inorganic impurities that are present in water. And the amount of chlorine that is consumed in the process of oxidation of the impurities or the microorganisms before any disinfection is achieved, that is just prior to disinfection, the amount of chlorine that is consumed for the oxidation, we call it as a chlorine demand of water. So after the chlorine demand is fulfilled, the chlorine will appear in the form of free available residual chlorine, that is the one existing in water in the form of hypochlorous acid or hypochlorite ions. And this free available residual chlorine will serve as a disinfectant in order to kill the pathogens that are present in water. So it is very much essential to provide enough time and enough dose of chlorine in order to satisfy these various chemical reactions and to leave some amount of unreacted chlorine as residual chlorine for the disinfection of water. So we can define chlorine demand as or it can be defined as the difference between the amount of chlorine which is added to water and the quantity of free available chlorine that is remaining at the end of the specified period of contact. So this is how we can define chlorine demand. Now coming to what do you mean by dosage, demand and residuals? So dosage means it is the amount of chlorine that is added, and demand is actually the amount of chlorine that is needed to oxidize the materials, and residual chlorine is the amount of chlorine that remains after oxidation. So residual chlorine is actually the difference between dosage and the demand. Now coming to the various forms of application of chlorine. So chlorine may be applied to water in various forms, and these are the most common forms by which the chlorine is applied to water. It may be applied as bleaching powder or hypochlorite. It may be applied as chloramines or as free chlorine gas or as chlorine dioxide. So bleaching powder is actually the most widely used method. Applying bleaching powder is one of the most widely adopted method for chlorination. So the chemical formulae for bleaching powder is CaOCl2. So bleaching powder, or it is also called as calcium hypochlorite, that is CaOCl2, is a chlorinated lime which contains 33 1/3 percentage of available chlorine when it is made fresh or when it is immediately made or freshly made. It contains about 33 1/3 percentage of available chlorine. And when this process of chlorination was introduced first, bleaching powder was very widely used, but it is not very stable, and it also loses its strength when it is stored for a long time or when it is exposed to air, and therefore it is used only for small installations or under emergency conditions. So earlier this was very much widely adopted or accepted method, but then when it is stored for a long time, it loses the strength, and also when it is exposed to air, the quality will reduce, and hence it is not widely used, or it is not used for large installations. Now this is the chemical equation. So when it is added to water, so this is the reaction which takes place. So here it is the hypochlorous acid which is formed, which will act as a disinfectant. Mainly it is adopted for the treatment of water in rural water supply schemes. Now coming to the next type, that is chloramines. So chloramines are actually compounds of ammonia and chlorine, and the widespread adoption of chlorine ammonia treatment followed recognition that the combination of chlorine and ammonia produces a more stable disinfecting residual than that produced by chlorine alone. So when we use chlorine and ammonia together, the residual or it is actually more effective, or it is found to be more stable than the disinfection process by using chlorine alone. And also here the free chlorine can react with the compounds like ammonia, proteins, amino acids and phenols which may be present in water, like I said, and it will form chloramines or any other derivative of chlorine which will constitute as a combined chlorine. So combined chlorine possesses disinfection properties. So it is more effective than using chlorine alone. So this is a chemical reaction. So which shows how what happens when it reacts with ammonia. So these are the chloramines that are formed for various values or ranges of pH. When it is less than 4.4, trichloroamine only. Between 4.4 to 5, dichloroamine only. Between 5 to 8, both mono and dichloroamines are formed. And for pH greater than 8.5, monochloroamine only. Now there are various advantages of using combining chlorine along with ammonia, or the advantages of using chloramines. So it is more effective, like I said, than using chlorine alone. It also prevents the taste and odor, so it reduces or prevents the taste and odor. And also the water treated with chloramines causes less irritation to the eye, because if it is chlorine alone, there may lead to irritation of the eye. Also not only eye, even to the nose and nose also. So it is more useful in treating water, especially when it comes to the treating water in the case of a swimming pool. So then we go for this method. And here also there is no danger of overdosing. So if you, in case the amount of chloramines added is more, it will not pose any danger. And here, since we are using ammonia in addition to chlorine, the amount of chlorine required is comparatively lesser. Now coming to free chlorine. So free chlorine means just chlorine alone, which is applied in the gaseous form, or either in the gaseous form or in the liquid form. So it is actually free chlorine is 2.48 times heavier than air and 1.44 times heavier than water. Then this is a very strong oxidant, and it also forms residual. So formation of residual whenever we use any disinfectant is very important, because during the process, like I said, during the process of distribution, there may be a chance for further contamination. So if there is presence of residual disinfectant in the pipeline, it will prevent the contamination, or it will further disinfect the water. And this free chlorine also will work under particular or specific values of pH. Now one more thing, the last one, or another form of application of chlorine is by using chlorine dioxide. So chlorine dioxide is actually created by mixing the solutions of sodium chloride and chlorine, and it is generated as per this equation. And the main advantages of using chlorine dioxide is that it is a very strong bactericide and virucide over a wide range of pH. So for varying pH, this can be adopted, and it forms a slight residual in the distribution system. So formation of residual is very important when it comes to disinfection. So, and it also does not react with nitrogen to form chloramines, and it does not react with organic matter to form trihalomethanes. Now, some examples of trihalomethanes are chloroform and bromoform. And the main disadvantages of using chlorine dioxide as a disinfectant are that it is very costly, and also it has a tendency to create chlorate and chlorides which are actually toxic. And chlorine dioxide is also used for treatment of for taste and odor control in the process of disinfection. So this is about chlorination, the different forms of application of chlorine. Thank you.